aim to explore how we could construct a payload for an airborne device to collect and transmit real-time environmental data, to then be processed using machine learning to make predictions for the future of the environment.
We can plot regression lines which will allow us to make predictions.
Interpreting data and visualizing it and comparing it to the real world scenario has been really helpful with just branching the gap between the theory and the experimental.
Machine learning is when you give lots of data to a computer, so it can learn to recognize patterns and make predictions given new data. We used Raspberry Pi devices, which are mini computers, alongside its peripherals, which use the air quality sensors and cameras for data collection.
I have a particular matter sensor here that takes in 2.5, 5 and 10 size particular matter, and that's connected up to a Raspberry Pi Zero, which is inside. Connected to Pi is also the camera, and you'll see that's pointed straight upwards, and then it's in the tube over here.
We also use LoRa radio, which allows for long-range radio transmission of the data collected from the airborne device for computer vision, feature recognition processing, and numerical sensor reading. This is important because it means that the airborne device doesn't need to return to the ground for us to manually retrieve the data from the Pi. We conducted 2 experiments on different airborne devices to ensure the Raspberry Pi could successfully collect data and survive the harsh conditions involved during high-altitude flight. We partnered with the Cambridge University spaceflight team to launch a high-altitude balloon alongside Launch Access Limited, who are experienced in educational rocket launch services, to also launch a model rocket in which data from the Pi was retrieved and processed.
With a balloon flight, you're taking 50 minutes to get to peak altitude, whereas with a rocket, you're taking 30 to 40 seconds.
However, the image data was too large to transmit. Our next steps will be to refine our experiments to tailor it for environmental observation. We collaborated with the University of Cranfield to build an automated plane for our Raspberry Pi payload in order to maintain greater control over the flight.
It can be flown in places that have no communications.
Using that shape so that we can have maximum number of solar panels collecting maximum energy so that we have maximum endurance.
We will use this plane to test our machine learning model and use live data to target tree observation to aid monitoring and preservation of biodiversity. We are in the process of developing an image recognition machine learning algorithm, which will run on the Raspberry Pi itself. Once images taken on the Pi during flight have been recognized, this information is converted into a textual format, which is light enough to be transmitted via LoRa radio and recreated on the ground as a simplified image.
I'm hoping to go into computer science and software engineering, and I think the biggest thing from this project is just learning more about how to use the libraries, how to clean data, how to use data to make predictions about the future, and learning more about machine learning. It's been really interesting.
There's no doubt that Python and coding in general is so important and a really valued skill. So regardless of my job, I'll definitely use the Python skills that I've developed in this project.